Welcome again for our mole lesson. Let us continue from where we stopped. Here I am tackling the several questions that are on my way to solve. So it is just a mole concept. Let me start right away. In a filtration question experiment, 25 centimeter cubed of a solution of sodium hydroxide containing 8 gram per liter was required for complete neutralization of 0.24 gram of diabacic acid. Calculate the relative molecular mass of the acid. So that is the question. Question it's solving relative molecular mass of an acid. But in our question we were told that there is two reagents, that is sodium hydroxide, which was in a solution form, therefore in a status of aqueous, plus diabacic acid. Because we don't know the name, or we don't know the figures of diabacic, we denote it with a known letter X, which will be also in aqueous form, which will give us on the other side, because remember this is a neutralization reaction, so this diabacic has a valence of 2, will form a salt plus water in liquid state. Let us balance the equation. We have 1 sodium, we have 2 sodium, so we put 2 here. We have 2 oxygen, we have 1 oxygen. Let us put 2 here. We have 2 hydrogen and 2 hydrogen. That's when you add 2 plus 2 you get 4. So on the other side, 2 times 2 you get 4. So the equation is balanced. So the mole ratio of the reagents was, we can derive it, mole ratio of base to acid will be 2:1. Then as we continue, we say that let us derive details from from our question. So 25 centimeter cubed of sodium hydroxide, which is a base, 25 centimeter cubed, 8 gram per liter, 8 gram per liter. So required for complete neutralization of 0.245 gram of diabacic, 0.245 gram of diabacic. So here diabacic is in unknown volume, but that is not much important to us. Our important details will be this, because here you can confirm easily that sodium hydroxide is a standard solution, because a standard solution is a solution in whose concentration is known. You can get that 8 gram per liter, that is concentration of sodium hydroxide. So we continue and say, to convert 8 gram per liter into moles, you will get that 8 gram are in 1000 centimeter cubed. What about in 25 centimeter cubed? You will get will get 25 centimeter cubed times 8 gram all over 1000 centimeter cubed. So 25 times 8, which is 200. So 200 all over 1000 will be 0.2 moles. After getting 0.2 moles, you come back here and say the ratio of base to acid, which is sodium hydroxide to diabesic. The ratio is 2:1, and we have already got the number of moles of sodium hydroxide. So unazileta hapa. After that, we ask ourselves, how will we get the moles of acid diabesic? So you will get them by multiplying the number of moles of base times ratio of diabesic over ratio of a base, which will give you 0.2 moles over 2, which will be 0.1 mole of. So our answer is 0.1 moles. That is the actual answer of moles. Then we continue and say, after getting 0.1 moles, it means this 0.1 moles is equivalent to 0.245 gram, because we were told this mass is the mass that was required for neutralization, and in our derivation ratio, mole ratio, we have seen that 0.1 moles required to neutralize 0.2 moles of a base. So 0.1 moles of diabesic is equivalent to 0.245 gram. Then for us to get relative formula mass, we ask ourselves, what about 1 mole? It will give us 0. It will be relative formula mass will be 1 mole times 0.45 gram all over 0.1 moles. Cancel that, you will get LFM will be 0.245 gram divided by 0.1. LFM will be 2.45, but because it is relative formula mass, we have no units, but that is the how to get the relative formula mass given such a question. Thank you for your watching.